Good afternoon, everyone. Today we're doing section 11.1, and this is where we're going to look at the difference between two proportions. We'll do a hypothesis test about the difference between two proportions. We'll even do a confidence interval, about that difference between two proportions. So this is the ending portion of our course, is chapter 11, where we're actually looking at different proportions. Next class we'll look at different sample sizes in terms of their means. So all this is inferential statistics. So what we're doing here is inferences about two proportions. You can always say that word, inferences. I mean, the author's title of this book, Inference About Two Population Proportions. So this is inferential statistics, but where we start is we get these samples. And that's why they have these hats on, okay? This thing does look overwhelming when you see it at first. I know that sample test statistic there that we're going to find. You're like, my gosh, good golly. So we'll use the technology absolutely to facilitate this. But if you want to do everything by hand, absolutely you can do that and do that. There's something new though we're doing here because we have two proportions. See this over here? This is called a pooled statistic right there. That right there. We've got, you see, we're going to have two different proportions. For a proportion 1, group 1, say it's the control group. All right, that has a subscript of 1. And then group 2, let's say that's the experimental group, right? They get the medicine, the real medicine. Remember we talked about that in this class. Control group gets like a placebo, right? Well, this right here in the math formula, they just pull it together, like putting everyone in a swimming pool. So they pull it together. It's a pooled statistic where p hat's just, you add the x's in both populations and you divide by the two sample sizes. So I just want to point that out because you're probably looking here going, where's the subscripts? Where's the sub 1 or sub 2? Which group is this from? It's a pooled statistic right there. So that's what it's called. But the technology will put all this together for you. And absolutely, please feel free to use that to facilitate the computations. What's important to us is being able to analyze this stuff, interpret things. It's going to be everything the same, everyone. So it's going to it should run smoothly. Like from that last test on chapters 9 and 10 with a p-value. If your p-value is low, what do you do about the hoe? You reject the hoe. I mean, it's the same thing. So that's what's awesome about this stuff. I do want to give you a couple copies so you can look at different ways people wrote explanations on the last tests. So if you missed something, you're like, wait, why did I get this wrong? What am I not saying in terms of creating a conclusion to a test? There is evidence or there isn't evidence. I do want to point out we're going to set this stuff up very similarly. It's going to be a similar way that we set these up. You will have two different proportions. So when we set this stuff up, we set up our hypothesis test, there's going to be two proportions. Population proportion 1 and population proportion 2. If these subscripts of 1 and 2 bug you, I've seen students before call this like group 1. Population for group 2. I've written it like that. But we're talking about two different proportions here. So we just give them subscripts. Not bad. Well, what's the null? That there's no difference. So for every one of these problems, that'll be our null hypothesis. Then, proportion 1 is equal to proportion 2. No difference. So that's always going to be our null hypothesis in this entire section. Hey, but you might have a left tail test. And you know what we'll do? What symbol do you think? It's like, do we draw two different bells? Nope. If you're thinking this is going to be confusing, absolutely not. We're still going to have this one normal distribution. We're talking about just the difference between these two. And left-tailed you'd shade where? Over off the left side, right? How much? Well, they have to give you that level of significance, true? 5% level of significance or 1%. What would it be if this was right-tailed? Right here you get this. Right down. We'll see when we read the problem what we have. I'll get this out of the way. Here. And what's the last one?
Is different or changed?
Yeah, so when we read the word problems on the book, we can kind of say something. Is it different? Is the difference different? Has it changed? we will do a two-tailed test. We'll have to take that alpha level, that level of significance, and divide by 2. So this would be all for these, but what would be the null every time? No matter what. I'm not putting hats on these, because we're talking about inferential statistics. We're talking about the population proportions. So I just want to point that out. That's how you'll set it up in this section when you're doing your hypothesis test.
I got a question.
Sure.
So since P1 equals to P2, so that means you're saying like when you have to take a sample, so if you take like 1,000 people for control group, the 1,000 people should be on the experimental group too? Is that what?
That's it.
That's it?
That's exactly it.
Okay.
So, all right, very good. And the problem we're going to start with is in page 540. It's number 20. So if you have your book, feel free to read along with me. It's on page 540. It's number 20. This is from section 11.1. But I'll write down all the statistics they get. They're going to look at 2 different proportions. Do you remember what a double-blind experiment meant? Yeah. Ooh, good, Randy. Yeah. Whoever's administered it, double-blind experiment. It's like a drug. Neither the doctor knows, right, or the patient knows what they're getting. Am I getting a placebo, or am I getting the real thing? Those are the best experiments. They definitely, the best defense against bias when you have this double-blind experiment. All right. Hey, we're going to go through the same stuff now. We're going to set up a hypothesis test, right? Then we'll verify our requirements, and you're like, gosh, what's the requirements going to be for this? It's not that bad. It's to remember the NP2 greater than or equal to 10? Mm-hmm. Same stuff. I'm serious. And it had to be less than or equal to 5% of the population. Same stuff, so we'll be okay there. Then we'll perform our hypothesis test when we'll state our conclusion. So that's what we'll go through, everyone. If you just want a quick, we're going to set up the hypothesis test. We'll verify our requirements. Shouldn't take too long. Then we'll perform the hypothesis test. We're going to perform it. We'll do classical and p-value approach. And then we'll state the conclusion. Okay, so we'll go through these things every time. Boom, 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 boom. And we'll start with number 20. All right, there's our sample test statistic for this section. All right, this is called the drug Prevnar. The drug Prevnar is a vaccine meant to prevent certain types of bacterial meningitis. It's typically administered to infants starting around 2 months of age. In a randomized, double-blind, clinical trials of Prevnar, infants, everyone, these are infants, were randomly divided into 2 groups. All right. Subjects in group 1 received Prevnar, while the subjects in group 2 received a control vaccine, a placebo. So we'll start with that, and when you're going to have a group 1, and there's going to be a group 2, they're getting the drug, they're getting the real treatment, they're getting the Prevnar. They're getting that drug, Prevnar. Make that really big, people can see that. Whereas group 2, that's your control group. They get a placebo or control vaccine. All right. Well, what's the numbers? They went out, they did this study. All right, after the second dose, they got 2 doses. This is what they saw. 137 of 142 subjects in the experimental group experienced drowsiness as a side effect. So let me put that down over here. This is group 1. The wording from the textbook. 137 out of 452. Don't we make that a p-hat? Mm-hmm. Yeah, so when they go 137 out of 452, you can think of that as 137 out of 452. This is group 1. That's your X, that's your N. Right? That's the proportion. Experienced drowsiness as a side effect. Now, how in the world do you know an infant 2 months old is experiencing drowsiness, I have no idea. I can't even. Hey, this is your X1, that's your N1. We just put subscripts like this. Okay, that's my P hat one. That's your P hat one, right? Well, how about the control group? How many experienced drowsiness there? 31 out of 99 subjects in the group, the control group, experienced drowsiness. Okay, over here, everyone, P hat 2, 31 out of 99. Drowsiness. Now, they didn't explain it in the study, but if some of you are curious why this is so low, and this is so high in terms of the samples, the way they distributed this, no idea, they didn't even talk about that. A lot of times they're close to each other, but it does indicate that these don't have to be really, really, really close to each other to do this stuff. But this was really done, so you're probably sitting there going, 99? This is 452 in terms of the sample size. That's X sub 2, that's N sub 2. X sub 2, N sub 2. All right. And we're going to read this question, then we can set up the hypothesis test. Does the evidence suggest that a lower proportion of subjects in group 1 experience drowsiness than those in group 2 at the alpha equal to 0.05 level of significance? All right, where's the yellow chalk? I'm going to put that level of significance down. And then for this problem, alpha equals 0.05. That's your level of significance. Read the question again. Does the evidence suggest that a lower proportion in this group experience drowsiness than this group? Okay? That's what we're running. All right, so we're going to set up this hypothesis test. Here's the setup. Null hypothesis H sub 0, H naught. And then the alternative hypothesis, H1. What's the null? That they're both the same, right? Set them equal. And don't put hats on them, these are rows. Row sub 1 equals row sub 2. The population proportion in group 1 is the same as the population proportion in group 2. In terms of drowsiness, right? Control group, just as drowsy as this group. That's our null, true? But the alternative, let me read that again, the question, we'll set it up. They go, does the evidence suggest that a lower proportion of subjects in group 1 experience drowsiness as a side effect than those in group 2? So this one has to be lower than this. How would you set that up?
Row 1 less than row 2.
I love it. I love it. I agree. Lower, this lower than that, this less than that. They said this lower than this less than that. That's probably the most important step to our whole process. We got to make sure we get that left tail test set correctly.
Sorry, I'm just going to back over. So
You bet.
The null hypothesis is just stating that that both groups experienced drowsiness.
That's right. You know, and we're saying not only that, that was good. They both experienced drowsiness, but the same proportion. Roughly the same proportion will be just as drowsy. It's not like we're basically saying, yeah, we get this. It's not like, oh, you take this drug, all right? It's to treat bacterial meningitis, but as a side effect, we're like, but is this going to make them really, really drowsy, right? That's what we're trying to see. And we're saying, the null hypothesis is no. No, you take this drug for bacterial meningitis, you're going to be just as drowsy if you just didn't take anything. Does that make sense?
Yes.
Oh, good. So that's what we're testing. That's our hypothesis test. And that's the setup. Everyone okay on the setup? Look, I didn't put hats on these. Right? And this is always the null. All right, everyone, we get to verify our requirements. Let's just verify our requirements. It may look long, but everyone, this is the same thing you've been doing, so have no stress. That's why I didn't have to pass out a document on this. I'm like, they get this now. Remember the n times the p times the q had to be greater than or equal to 10 with proportions? Well, I just have to do 2 of those. So here I go. I just got to put subscripts of 1s. N sub 1, npq, greater than or equal to 10. And I will just put subscripts of 1s. That's it. That's for group 1. Everyone, I have to put hats on these because we don't know the proportion yet, right? No one gave us some proportion out there. There's no like official doctor group that said, here's the proportion that's going to, experience drowsiness. So we're using that, the actual sample proportions as an estimate. Oh, I gotta do one for the 2s. Here we go. N sub 2, P hat sub 2, Q hat sub 2. Great equals that. We just gotta check this. Anything else? Oh yeah, do you remember this? Do you remember the sample size has to be less than or equal to 5% of the population size? So let's add that too, okay? N sub 1 has to be less than or equal to 5% of population size 1. N sub 2 has to be less than or equal to 5% of N sub 2. Do not let this bug you. But we do just have to verify this stuff to make sure the distribution that we're going to deal with when you and I go like this, that we're allowed to do this, that this is going to be allowed, that the distribution is approximately normal. That's all. Is this sample size big enough so we can do this stuff? This one, I know we're good to go there. I want to make sure we do that calculation. Because that sample size, everyone, was only 99, right? So I want to make sure that's verified. I haven't checked it yet. We'll just grab these numbers out of the book, but is that number right there times this proportion times 1 minus that? Keep in mind, these Q's just means 1 minus the P hat. Always remember that, by me writing that. It just saves so much room. And when it makes it look so much more complicated, when you gotta go, P hat 1 minus P hat there. That's all. All right, can we verify this? This is the only boring part. I admit, this is the only boring part. We gotta verify this. Oh, did they say anything about it being random? You remember that? They said it was a randomized, and it was double blind. So if you wanna, that's actually part of the requirements that we're actually saying. We're starting from chapter 1 in this book that, hey, you doing it randomly? And it being double blind is even better. It's a very effective experiment. So that's part of the course over in this stuff. You go, why? You might find yourself doing something like this. Well, it might not be a drug, but I mean something in your field of expertise. I'm being honest. You might find yourself doing something just like this. You report it. Heck, it might be for like your PhD. You could be doing a dissertation or something. You'll go out and get a sample, another sample. You may find yourself doing this. You won't even have to email me, right? You'll be like, I got his notes. I forgot to do this stuff. I know how to set this stuff up. All right, everyone, this is the one. I'm sure this is good to go. This one too, everyone. We're talking about infants. Don't you have millions of infants? Mm-hmm. So you're going to be less than that. That sample size is definitely less than 5% of millions. Let's make sure this is true. I know this one's going to be good. This one right here. Well, let's just see. That's 99 times, what's the P hat? That'd be what's 31 over 99?
0.3. Like
That's about 0.3-ish.
0.31.
It's about a 0.31. And then what's 1 minus 0.31?
0.69.
Like a 0.6. Let's just make sure. I know we rounded those, but it's okay. We just make sure it's higher than 10. Higher than 10? Question mark? Higher, is it?
Yes.
It is? How high?
It's 21.
Oh, see, we're good. It's 21. We're good. And we check it off. Give it a check. This one's good too. 99 is less than 5% of millions. 1 million. 2. If this one's true, this one's definitely true. That's my point. You're like, I know that's good. And that's all we got to write. That's all we have to put. And it was random. We're good. It was randomized. I'll put that in there. It was randomized. All right, now we get to have fun. But now, is everyone okay with this? We're not going to sit here and kill ourselves, what? Right? We're going to use the technology to compute this for us. That sound good? That's the idea. Let it facilitate this. We're going to interpret this. We're going to go through. We're going to, I'll get a p-value. There's the outflow. If your p-value is low, reject the hell, right? Okay. We'll make a little left-tailed test here. We'll shade 5% on the left side. This is proportions, everyone, so this is Z. So when we do this stuff, this is not T, this will be Z. We'll shade it right here. We'll shade that. And if it falls in there, we reject the null hypothesis, right? Cool. So is everyone ready? All right, we're going to do the classical approach. Let's have some fun. And we'll do the p-value approach. Classical approach. Go ahead and draw a bell. I like to put Z or minus for doing Z. What's Z equal to right there?
0.
0, 1, 2, and 3, these are all negatives. What's Z put over here? This is really all about pictures, though, and that's why I always draw a picture. These hypothesis tests, we got a distribution going on here. Now I'm going to shade 5% for the left side. All right, 5%. I don't know how far to go, Owen, but we'll just shade. 5%. Not drawing a scale, but it is a left-tailed test, so I do have it shaded on the left. Not drawing the scale, it's not a perfect valve, but definitely finding out. Yellow chalk, so I'm going to drop my white chalk. Yellow chalk. Just like before. Nothing's different. I'm going to find my Z crit. I'm going to find my Z crit. This is Z's, so I got to find my critical Z score. I know it's going to be negative. Let's talk about technology. How do I get the Z crit with technology?
Inverse norm.
Inverse norm. Inverse norm, what percent?
0.05.
Yeah. So if you want to use your technology right now, hit inverse norm 5%. A lot of us are like, we get it off the what?
Chart.
Right, everyone? A lot of us get it off the table, so let's get our tables. Anybody need an extra T table, Z table? Sometimes they get lost, you know? You take a test, you throw it in a trash can or something by accident, like, yeah, go and test. But I have extras here if you need. So you can read it off here. This is a T table. At the very, very bottom, what row do we have? Z. So I'm going to look at this thing. And I'm going to verify. Anybody already hit on a calculator? I'm going to verify with you there, Art, because I know you just typed in inverse norm 5%. And right here, he's typing inverse norm on his calculator 5%. I'm looking on this sheet, and at 5%, it says 1.645. Now, does anyone know why I'm making it negative? It's on the left side. That's why I made that negative. So you can use your table, or you can use technology to get this. All right, cool. Drop this. Everyone, it's the same story. If look at this thing. If that number falls in here, based on these two proportions, we're going to reject the null hypothesis, right? We'll get a p-value. If my p-value is low, we're going to reject the null. There's no way you can miss unless I accidentally type in the wrong number in my calculator. I'm being serious. Now, I bet you can predict where I go on my menu. So I bet you can find it. So these are proportions, right?
Stat test.
I'll go to stat test. I'm not doing this by hand unless you want it. What's this for?
I think number 3, this one.
Stat tests. Well, it's a hypothesis test. It's a hypothesis test. But this is for how many proportions?
One
proportion. This has
two
proportions. So we're going to use 2 prop Z test. 2 prop Z test. Right? And when you see the setup, you're going to know exactly what to type in. Check this out. It's number 6. So you go, okay, in 11.1, I use number 6 every time. True? And I hit it. All right, what goes there? What's the next of 1?
137.
137. What's sense of 1? A 4, 5, 2. All right, what's x of 2?
31.
See, it knows you have all this stuff. You get 2 proportions. 31 out of 99. Which one do we want?
Less than, right?
Yeah, left tail test. So make sure box. Calculator draw, I like calculating. If my p-value is low, reject the hell, right? That's the first thing I look at. Look at the p-value. Lower than 5%, is it?
No.
Right there.
Way greater.
Way greater. Do not reject the hell. We know the entire answer. My conclusion, there is not sufficient evidence suggesting that the proportions are different. So this drug, take the Prevnar, it's not going to make them like more drowsy, that's what we're saying. Yeah. They're going to be way more drowsy. Not with that p-value. Everyone, is it unusual to get things in this world? There's a 42% chance of something happening.
A lot.
It's not unusual, it happens all the time. Right? Right, exactly. All right. Hey, they gave us some other numbers. Did you notice they gave you a little pool p-hat? Isn't that nice? If you wanted to know what it was. There's that pool p-hat, but it did all the computations for us. So you might even ignore this. There you go, thanks for doing that, but this was really the number I wanted. And that number too. These are the two numbers you want. That one and that one. Here, I'll hit the laser. If it shows up on that camera. I want that number, and I want that number. Those numbers, that's the p-value. That's just p-hat 1, p-hat 2, that's just the pool p-hat. Which allowed us to do all that right there, instead of sitting right there. Thank you, you just saved us a lot of time, right?
I mean, we're just looking for just the P.
You got it. Randy, you're absolutely correct. That's what I wanted. But Randy, let's use that number 2. Because we can draw it in our nice bell for the classical approach.
Right.
Cool? All right. Okay. But it's really the p-value. Y'all agree? That's what we concentrate on. So I'm going to hit it. And when I'm going to perform the p-value after I finish the classical approach, and we'll state our conclusion. What was this number again? This is called the
Z0?
Yep, I always like to write it out in words.
Sample statistic.
Yeah, it's a sample test statistic. That's what it is. It came from our sample. It was that gigantic expression right there. And this number came out to be roughly negative
196.
0.196 or negative 0.2. Let's draw it. Boy, did I love it at last test when you all drew this in your bell. I love it. Where is it located?
All the way to the left.
It's about right there, isn't it?
Yeah.
It's like a hair left to the 0 mark, isn't it? It's right off the 0. It's about right here. I like to, it's like, give it a little, here I'll get the Z out of the way. It's right there. There's my Z naught. It's right there. But it's not even close to the what? The rejection region, right? Where you reject. It's called the critical region. But it's not even close to that. All right, there's Z naught. I want to negative 0.196. Right there. P-value approach. This will be quick.
Don't you need to write the conclusion, like there is no evidence? Do you have to?
Absolutely, and some of you might have already written it. Art, very good point. Some of you may have already stated your conclusion because you knew it. You knew it right away. I'm gonna write out the p-value expression and then state my conclusion. So Art, very good. You could do it right away. Once you found that p-value and you saw this number wasn't in this region, right? Hey, my p-value was like 0.42.
Yeah.
Oh my gosh. And so I'm just going to interpret that on this right here. You go, what is it? It's a probability. It's the probability that, see this number right here? That my test statistic was on the left side of this negative 1.196. So I mean, could you imagine if I shaded from here over? Isn't that a lot covered? Yeah, like 42%. That's what that really is. This came from this. I always want you to know, where did the p-value come from? I always want students to know that. You go, what is a p-value? So I always interpret. Every time, I always interpret the p-value. This is the probability of obtaining these statistical results. These statistical results if these are equal, right? Well, because, I got a period there, because my p-value, hey, you know what when I put it, obtain these statistical results, some of you may say or more extreme, but I got it written right there. So since I stated it right here, I didn't have to say or more extreme. Because my p-value is it lower or greater than?
Greater.
Whoa, yeah, way greater than the what?
Alpha level.
This was a 0.42, this was a 0.05. Because it's way greater, what are we doing about the null?
We do not.
We do not reject the null. Sierra says we fail to reject the null. So you can say it either way. We do not reject the null hypothesis. We keep it. Well, we can't write that. We keep it. We can't write that. Why not? It's like saying the person's innocent, right? We just say we find them not guilty. Same thing. We do not reject them. So hey, I'm going to state my conclusion. Conclusion! Boom, boom. There is sufficient evidence, or there is not sufficient evidence. I want to make sure I don't mess this up. This was not in here. We do not reject the null. I'm going to mention this right here. That's what I did this entire test for. I spent a lot of time getting these people in this experiment, all these infants. Took a lot of money too, a lot of time and effort. Well, what's my conclusion? There is not sufficient evidence suggesting you can't use words like prove because it's not literally a math proof. So I don't say proving. Suggesting that row 1, what's that in that alternative? That this is lower. There's not evidence that this is causing drowsiness. Hey, if you want to put them in words, say it like that. Speak about the bacterial meningitis and about this drowsiness. There's just not evidence that this drug Prevnar is what? Making those infants more drowsy. How about that? Right? They're not going to be more tired. Cool. Alright, so maybe this was lower than this, but the results were not statistically significant. That's how we speak in statistics. It's a good job at this, everyone. Hey, do you remember confidence intervals?
Mm-hmm.
You mind if we just look at it for this problem real quick? Let's just look at a confidence interval. Confidence intervals for two proportions is real easy. You know, when would you reject the null off a confidence interval?
When if it is that is not within that p-value.
Yeah. And when it's really about a difference, it's really about a difference between these two proportions, okay? So I'm going to look at a confidence interval about the difference. If the difference traps 0, then I can't reject it. Does that make sense? If somewhere in the difference confidence interval 0 exists, then we're saying, oh yeah, you're confident that it's not going to have any difference. Does that make sense? I'll say it again. I'm going to look at the confidence interval for this thing. I'll go bust out, look at it with the calculator. We'll go hit the other thing. We just did 2 prob z test. I'm going to hit 2 prob z interval, right? But if that interval contains the number 0, that should give us further evidence. You can't reject the null. Because if it contains 0, you're saying, yeah, you're really confident that there's 0 difference in there. You're really confident. There's no difference between them. So everyone's going to hit 2 clicks of the button, I think. I just got to click over to what? This is the best thing about the calculator. That's what I want to show it to you right now. Everyone, I'm just going to switch over real quickly. Boom. I was on stat z test. But I'm going to go to, I'm going to bypass that, to a 2 prop z interval. It's letter B. Well, I want you to see something. Look what the calculator does. It keeps my same one. I don't have to re-enter these. Isn't that neat? Mm-hmm. Now, let's talk about that confidence level. You go, what would you want to type in? Well, let's look at this picture right here. Remember, confidence intervals are from the middle. Confidence intervals from the middle. So 5% here, then that would mean I'd have to think like 5% on the other side. So how about we do 90% from the middle? Is that okay? So when I'm going to hit 90%, oh, it's already on 90%. I'll scroll down, and we'll talk about this. Check to see if this interval contains the number 0. That means it goes from a negative to a positive. Does it contain 0? Is a 0 in the middle of these? Somewhere in that interval? Then we can't reject the null hypothesis. That's the idea. Look, I'm going to interpret this real quick. I'll make another sentence. I am really, really confident. I'm 90% confident that the difference between them contains a difference of 0. That the difference between these proportions is no difference. Difference 0 means these are equal. Alright? So that's what I'm saying. Does that make sense? I'd just like to tie everything we've done before in this course.
So even though when we're like writing out like how we have to we fail to reject the null hypothesis, we're technically saying that we're keeping it. So
I know.
So that's further like I can't.
Evidence.
Yeah, that we can't. keep it,
Brilliant.
Right?
Sierra, brilliant. You get, this is just further evidence. And what I love, Sierra, I didn't have to hit much more on a calculator, did I? Just further evidence, indicating, suggesting that there's no difference between these two proportions. I am really, really confident that the difference between those two population proportions is between these, but furthermore, contains the difference of 0, right? Now, if it didn't have a 0 in the middle there, then we would be rejecting the null also.
Do you have to find margin of error or anything for this?
No, you don't. But I'll do a separate problem. I just want to do it for the next one. How about the next problem? We won't set up the hypothesis test. We'll just do a confidence interval. And what we'll do is we'll say, how do you all like to say it? You either go, I am 90% confident, or you can go, with 90% confidence, and we'll make our statement. But the key is what I want you to look for, Randy. Does the interval contain a number 0? And if it doesn't contain 0, all right, now you got evidence. You're really confident there's some kind of difference there.
Okay.
Isn't that cool? So I'm going to pick a problem out of the book. All I want you to do right now is a confidence interval. That sound good? Super job with this, by the way. Seriously, really good. Don't you love, this is my favorite part. You go, why? Because of all the stuff we've done in this course, this is something you might find yourself doing. You might not see it now, but wait 3 years from now. When all of a sudden you're like, okay, I got this, now I'm working on my master's and I got to do my thesis. And my professor wants me to go out and do a study. I mean, you might find yourself doing something like this. Your major might be at University of Maryland criminal justice. But you might find yourself just getting a control group, right? And some experimental group for what you're looking at in your field of expertise. It's kind of neat. You go, oh, I'll do a 2 proportion Z test. And I'll write up Sierra, 2 proportion confidence interval with Z interval. All right, let's do another one. Great job with this. All right. I'll read. And I just want you to do a confidence interval. Which one had a confidence interval? They usually do confidence intervals if it's a 2-tailed test type of setup to a hypothesis test. And when it's number 24, called body mass index. All right. Body mass index. I'm curious who they're comparing now. I have a feeling I know though. All right, who are they comparing in this problem? Who's group 1? Who's group 2? And this was infants with the Prevnar drug. It's the control group. But maybe this time it's not drug and placebo. Maybe they just got 2 different groups. You will find yourself, though, with these proportions. 2 different proportions. I knew it. And when they're comparing men and women, they do this all the time, don't they? The body mass index of an individual is one measured that is used to judge whether an individual is overweight or not. Okay. Yeah, we know that. Body mass index. Overweight or not. This is what they use to indicate whether someone's overweight or not. They call it a BMI. And when a BMI between 20 and 25 indicates that one is at normal weight. In a survey of 750 men and 750 women. I'm going to start there, and how about we just group 1 men? Since they went in that order, group 2 women. I know it wouldn't matter, but let's just go with that. Do I have to make group 1 men? No. But they went in that order in the book, I'll just go in the order they had in the book listed, men and women. This was 750. Sample size. This was 750. Okay. What else they got? 203 men and 270 women were normal weight. 203 men. 270 women. 270 out of 750 women. Normal weight. This is normal weight. That's what they found. That meant they had a BMI in that 20 to 25 range. Normal weight. Men, normal weight. Okay, hey, can you just wait? Which group seems to have more of a weight problem?
Men.
Men. Yeah, I know. Pizzas. We're not exercising. We got the Looks like we got the weight wrong. Normal weight. Okay, there's the proportions, BMI, between 20 and 25. The book says, can you construct a 90% confidence interval to gauge whether there is a difference in the proportion of men and women who are normal weight? I'm going to write that out, just so you know the direction. Can you construct a 90% confidence interval to gauge rather there is a difference in the proportion there's a difference in the proportion of men and women who are normal weight. Who are normal weight. So when you and I are going to construct, I'm going to write 90%. I'm going to go like this. I'm going to put CI for constant, and I'm going to put an equal sign. So let's just use this technology at our side, this TI-83 or K-84. We'll construct this. Sound good? Unless you want to, can I do this by hand? And when I'm going to write this out on the board here, you do not have to copy this. But it would be like this. This would really be a P hat 1 minus P hat 2. That would be that's your point estimate. Plus or minus. And then you got your either your Z1 or your Z2. Per root. P hat 1, Q hat 1 over N1 plus P hat 2, Q hat 2 over S2. That's if someone wanted to do this, I don't know, with a scientific calculator. Or they're using a Microsoft Excel and they just want to type these numbers in. That's my point estimate, the difference. There's my standard deviation. This means how many standard deviations away from the mean. Just like before. All right, let's use this. Let me hit the lights. Ooh, it's a 90% confidence interval. We're looking at 2-prompt Z interval, right? Stat. Test. 2-prompt Z interval. 2-prompt Z interval. There it is. How many men? 203, 750, 270, 750. Confidence level is 90%. And I calculate. What am I looking for? I am looking to see whether or not this interval contains a 0. Is 0 in the middle of this interval? If it is, I'm shrugging my shoulders. I can't reject some null hypothesis. But if it doesn't contain 0, then we've got strong evidence suggesting that there is a difference in the proportion here. I mean, everyone, we get it. Are these two proportions different? Yeah, they're different. We know that. We don't need a course for that. What we want to know, are the results statistically significant? I'm going to find out right now. Calculate. Does that contain 0?
No.
They're both negative. No. We've got evidence. And when there is a difference, it's statistically significant, our results. We're saying these results are statistically significant. They're not only different in proportion, they're statistically significant, these results. There is evidence suggesting that, more men are overweight. Period. That's what we're saying. In terms of the population. Absolutely. I like the lights. Somebody was it negative 0.13, comma negative 0.05? That's okay. I write it like that. Can I erase the formula? Yeah. I don't know if anybody wanted to do that by hand. Can we interpret this? With 90% confidence, what do we know?
appears that it's just enough more than our voice is moving.
Yeah. Yeah, we're not 90% confidence. This interval. This is the difference. Difference in the proportions. This interval, which indicates I'll just say this. The difference. I mean, just keep it simple, right? Straightforward. With 90% confidence. The difference between the two proportions, men and women. I'm talking about population proportions. Does not contain 0. That's what I was looking for. It does not contain a 0. I can put in parentheses. What does a 0 and difference mean? That would indicate what? You know, that would indicate no difference. A 0, right? But with 90% confidence, the difference between the two proportions, men and women, does not contain a 0. You could say it's between these numbers, which is fine, but it's what Randy's saying. So we now have what? I can put a conclusion with this too. There's evidence suggesting more men are overweight, right? That's what we're saying. Well, what are you trying to say? This is what we're trying to say. The difference was not 0. It didn't contain a 0. The difference in the proportions. If it contained a 0, we're saying, oh yeah, no hypothesis, the two proportions were equal. Isn't that cool? Hey everyone, we'll do one more problem. This problem we won't write up everything, but let's just stare, find p-value, and be able to talk about what the conclusion will be. That sound good? Because I know you can always write everything up, make a nice picture. We'll talk about is it left-tailed, right-tailed, or two-tailed. Do one more hypothesis does. That sound good? Super job with that. All right, last one we're going to do. Great job, everyone. I'm going to do, this is number 22, view on the death penalty. I'm trying to do the even problems because all the odd problems are good. Go ahead, Sierra.
Sorry.
Oh, go right ahead. Go back to this.
Since there is 0, or since there isn't 0 in the two between two intervals, then we reject the null hypothesis.
I love it. I'm going to repeat what she just said. Perfect, Sierra. If this interval right here, and you could do this on any hypothesis test if you want to. If this does not contain a 0, reject null hypothesis. Now, I never wrote a null hypothesis here, but this is what the null was. It's the same thing as what we're doing. If these proportions are equal. Well, here, I'm going to put an X. We're rejecting it. I'm going to reject this thing. If the interval does not contain a 0 in the middle, it means you're really confident you don't have the 0 difference, that they're the same. Good job. So feel free to even do that on any problem. Add that. Like you said, it's just further evidence. All right, well, this is number 22. Views on the death penalty. Oh, gosh. Don't you go, these two groups are, this is hilarious. Group 1, everyone. This is number 20. 2. Death penalty. Pew Research did this. Did they give a year? No. Are you in favor of or opposed to executing persons as a general policy when the crime was committed while under the age of 18? Let me repeat that. Pew Research Group conducted a poll in which they asked, are you in favor of or opposed to executing persons as a general policy when the crime was committed while under the age of 18? And this is for capital punishment. Group 1, Catholics. Who's group 2? Seculars. Oh, this was Catholic. This is secular. All right, let's see what we get. And group 1, 180 in favor of capital punishment. 180 out of 580. So not normal. In favor of capital punishment. How about group 2? How many in favor of capital punishment? 238 of 600. 238 out of 600 in group 2. This is P hat 2. These are the seculars. In favor of capital punishment. All right. Let me read the last question. Is it going to be left tail or right tail? What are they trying to test here? Is there a significant difference in the proportion of individuals in these groups in favor of capital punishment? Let me read that again. That didn't say less than or greater than, did it?
Difference.
Difference. Listen, let me repeat this. So I'm going to set eyebrows and go, is there a significant difference in the proportion of individuals? So that means two-tailed test, doesn't it?
Mm-hmm.
They didn't say, is Catholics greater, is the seculars less than group 1, group 2, or anything like that being less than or greater than. It says a difference. So when we set this up, we know what the null is. Proportions equal, but what's all our alternative hypothesis? Not a two-tailed test. All right, we'll verify the requirements, but we want to just get to this. If I shade two sides, I'll see what the alpha level is. You know, got a two-tailed test. Like I said, I mean, we won't write everything out, but at least we can put some notes down. We're going to look at the p-value. You got that? What's the level of significance? Do you notice a lot of times they use 5%? A lot of times they use 5%. This time it's 1%. So here's your level of significance. It's 1%. It's a 1% level significance. But it's two tails. So how much is in this tail?
Divided by 2. Alpha over
Can
alpha.
somebody do that in their head, or somebody do it mentally? What's this? Level significance divided by 2. 0, 0. I'm going to write that. When there's your, it's not a z-score. That's my alpha on this side. They call it alpha divide 2. You've probably seen that in the book. I'll get that z-crit. Here's an alpha divide 2 of 0.005 on this side. All I did was take that 1% and divide 2. But I want to see what my crits are, my z-crits. You want to use a table? Ooh, the table does have a 0.005. You want to use inverse norm? What's inverse norm of 0.005 coming out the big? I'll use this. My table is saying 2.576. Do you all get that?
Yes.
That's from the table. The negative 2.576. That means this would be a 2.576, right? This is negative. That's a negative, that's positive. There it is. Wow, I guess it wouldn't be shading so much, huh? It'd be not much to shade. That's close to, it's getting close to like, I just want to make this picture a little more appropriate. That's really close to the end where it just starts leveling out, right? There's not much in these tails here. I'm shading more for emphasis, right? Negative 2.576 and this. And we're going to get a p-value, true? All right, where do we go? 2 prop what? 2 prop z-test. Stuff's a blast. 2 prop z-test. Best part of the course. By far. By far. I love looking at different proportions. Next class we'll look at different means. Okay. So what do we have? Catholics, 180 out of 560. Capital punishment. Pew Research did this poll, 238 out of 600. Okay. Are the results statistically significant? Which one do I use? Two-tailed. Look for the p-value. But your p-value has to be lower than 1% to reject the null, right? Right, Liz? That's what I'm looking at.
So can you repeat the question?
You bet. So in this problem here, we want to say, oh, you know, are our results statistically significant? We're going to conduct this hypothesis test. I drew a nice picture and stuff. We'll get our sample test statistic, this thing, but I always look at that p-value. And we know, right, if our p-value is lower than this, we're rejecting the null. That's what it's all about. Well, that was close, but we're rejecting the null. Does everyone agree? See it right there? 0.007. Is that less than 1%? Check. Reject null.
So we're not looking at 5, we're looking at 1.
That's right.
Okay.
Very good. The key thing here was when we did this, we can even put this number in here. I think it'd be great to you. You see that Z right up there, the top one? The negative 2.67? We can put it in our image. It was the sample test statistic, which was negative 2.66. Where is that?
That's not the same thing at all.
Oh, it's different? Oh, you're the best. Let me go back. What'd you get? Two prop zetas.
It's 580.
Oh, it's 580? Is that M1?
Yeah.
Oh, you're the best. Everyone, I apologize. I put a 560 there. It's 580. How about these numbers? Are those okay?
Yes.
Is 0.001 less than 1%? Yep.
Yeah.
Cool.
Hey, I'm going to put this number down. Thanks again for noting that. What's that sample test statistic? Negative 3.09? Where is that? Where would that be? Right there? Does everyone agree it's right there? So it's in the region. What's our p-value? 0.0019 or 0.002? This is lower than the what? It's lower than the alpha. So what do y'all think? Reject the hoe. There is sufficient evidence suggesting there's a difference in these proportions who favor capital punishment. That right there. Hey, as you're packing up, I do want to point out one important thing. And when I like, this stuff's real life, right? Well, there's another phrase. All day we've been looking at whether or not our results are statistically significant. And when the results are statistically significant, but this is just something I'll hit on next class too. You know what else we should look at? Are the results practically significant? So can I give you an example? Let's say we have evidence that we're taking a medication for allergies. Anybody have allergies? Because they're annoying. You take a medicine, but we find out that there's evidence that that drug that you're taking for your allergies actually causes headaches, right?
Yeah.
The results are just statistically significant. Now here we go, okay. Yeah, the results were statistically significant. The p-value is lower than the alpha level. But here's the deal. Are the results practically significant? A lot of times we say no, and you go, why? Because I'll take the little headache as long as I can kind of breathe during the day, right? What I mean is, I want to take this medicine because it's taking care of my what? My allergies. So while the results were statistically significant, you know, we would say, no, they're not practically significant. Because we'll still use this drug, it's still out there because it does help people out during the day. They can get through their day. They don't mind this tiny headache or the probability likely to have that headache.
So is there also like within 5% range of practical?
That's it. Have a great day. Yep.
Oh, 5% also?
Yeah.
Oh.